The UK Space Research Centre in Leicester, primarily developing space-age technology, is finding some of its more innovative work can be applied to more earthly issues, such as healthcare. The scientists say they have had significant breakthroughs in bioimaging and scanning, and these developments can be applied to X-ray work in hospitals and research into cancer and poisoning. Their work on the two areas of cancer and poisoning has huge global significance, as survival rates are significantly improved if caught early enough. Though based in the Midlands in the UK, the Space Research Centre has collaborative partners all over the world, in continental Western Europe, in Japan, in Russia, in India and China. The future for the Space Research Centre looks healthy. Its scientists will continue to work with their global partners on innovative medical advancements and are confident that the next 40 years of space travel will be as wondrous for mankind as the last. NASA called this the Demonstration of Autonomous Rendezvous Technology, or DART. And with its robotic vehicle, NASA will literally throw up an unmanned DART into space to see if it can link up with another spacecraft. They're hoping the new technology will allow a spacecraft to pinpoint and rendezvous with another craft without human guidance. They also believe such technology could help take humans back to the Moon and eventually to Mars and beyond. NASA says a series of ground tests demonstrated the capability of DART hardware and software to communicate and drive a spacecraft without human guidance, achieving both a close approach to its target and a safe rendezvous. It was launched from a support aircraft some 40,000 feet over the Pacific Ocean. It will pass over each pole approximately every 99 minutes. Once on orbit, the DART craft will travel around the Earth to rendezvous with its target, a 105-pound target satellite. The satellite was designed for use with a video guidance system such as the one on board DART. Mission planners want the 24-hour DART mission to be accomplished without human intervention as part of the test. NASA says the ability of unpiloted spacecraft to dock in space is the first step towards delivering equipment and supplies to the International Space Station, as well as conducting service missions to the station. The technology could also help when retrieving satellites or servicing civil, defense or commercial space transportation space missions. During the ground tests, NASA said a number of maneuvers were demonstrated, including a collision avoidance maneuver, horizontal approaches toward the target satellite, and moving to a docking and hold position to within 16 feet of the target satellite. Because of Mars' low atmospheric pressure and low temperatures, water can't exist in liquid form. It must either freeze or evaporate. But while there are no oceans or rivers on Mars, there is more water in total than anyone had expected. The residual polar cap in the north, which remains after the hottest part of the northern summer, is water ice mixed with dust. And the measurements of the seasonal behaviour of the water vapour over the planet suggests there is a vast reservoir of ice beneath the surface, so that one can think of the residual polar cap as the tip of an iceberg protruding from a sea of rock. At lower latitudes, a water vapour condenses to form clouds that ride high in the atmosphere or swirl around the slopes of Martian volcanoes. And further south in the canyons and valleys, there is frequently an ice haze seen to form and evaporate in the early hours of the morning as the sun warms the atmosphere. In this model, the flat surface of a large Martian plateau is cut by the Great Rift, A smooth, sloping ravine drops abruptly to the bottom of the canyon 4 miles below. The small peaks on the canyon floor were once part of the plateau's surface. Today, this great fracture in the crust of Mars is 75 miles across. The original fault has been widened and shaped by various forms of erosion. Great landslides are triggered by quakes that shake the crustal rocks. Wind-blown dust strips the canyon walls. Some side canyons may have been deepened by running water. Melting of underground ice, followed by slumping of walls, further erodes the Great Fault. This Rift Valley, of which we have only seen a small part, is so huge that it would span the United States, and the Grand Canyon of Arizona would fit inside one of the smaller tributaries. These are just some of the mysteries of Mars, unlocked by the extraordinary Voyager missions. Named after the stone tablet that unlocked the secrets of Egyptian hieroglyphics, the Rosetta ESA mission aims to unlock the secrets of how the Earth was formed, with British scientists and technicians playing a leading role. The Rosetta probe consists of an orbiter and lander module to be sent into deep space to rendezvous with one of millions of comets orbiting the Sun. Comets are believed to be leftovers of material that eventually turned into the solar system. If successful, the mission could reveal how the planets and even life itself evolved. The Rosetta is bound for comet 67P Churyumov-Gerasimenko. It's only 2 kilometers across, and the probe must be precisely navigated over hundreds of millions of miles. When the probe arrives, mission scientists admit they've no idea exactly what they'll find. Rosetta is the first ever space mission to attempt a landing on a comet, a remote laboratory heading into the unknown in an attempt to answer some of the most fundamental questions facing humankind. This is the most distant point we've seen across the universe, thanks to Hubble. It's one of the last in a long line of telescopes. And many of its forebears are housed here at Munich's Deutsches Museum. They may be antique, but the principle remains the same. It allows us to see deep into space. Hubble has been orbiting the Earth since its launch in April 1990, a shared project between the European Space Agency, the United States, and Canada. It has allowed scientists to push back the frontiers of space and their understanding of the origins of time. The giant telescope, orbiting at 600 kilometers, is able to produce images unaffected by the Earth's atmosphere. 33-year-old Dane Soren Larsen is one of the astronomers at the European Southern Observatory in Munich, able to interpret discoveries made by Hubble. Powerful Earth-based telescopes like this one at Paranal in the Chilean Andes complement Hubble's work thanks to their arsenal of technology. All the data received by Hubble is transmitted first to the operational headquarters in Baltimore and then sent via the internet to Munich. Maintaining Hubble was made possible thanks to the shuttle and its crew, a fact underlined by Bob Fosbury, an expert in ESA's Hubble department. As Fosbury says, Hubble had teething problems in the early days. Once the shuttle's astronauts rectified the problem, everything came into focus. According to Fosbury, the answer in the future to Hubble's many problems might lie in robotics. With the use of robotics and relying on batteries and gyroscopes, it is hoped that Hubble will last at least till the year 2010. NASA scientists say it's hard to predict how long Hubble will last. NASA must make a decision soon on whether to send a robotic crew to carry out the minimum of maintenance that will protect Hubble. The Hubble telescope has already been responsible for a whole galaxy of fantastic images. This town in the French Pyrenees is a village that the youth organisation Planet Science welcomes 25 teenagers every summer for 3 weeks of scientific discovery and relaxation. This unusual summer camp creates a fun environment in which these 13 to 15-year-olds can take on technological challenges. For example, here they're building robots. A field has been transformed into a launch pad, and the children's micro rockets are almost ready for takeoff. It's one of the highlights of the camp, and everyone's very proud of their creations. They've even named them. The rockets have been built under the supervision of camp staff with all the necessary safety precautions. Even still, they should be able to reach heights of 200 meters. As the countdown begins, the tension mounts, and the looks on young faces say it all. Perfect takeoffs. Or almost anyway. But at least everyone's had fun. And here's where the most serious carry out a range of experiments using real sounding balloons. Atmospheric pressure, temperature, all is monitored on the ground by the project's creators, Matthew and Nicholas. They explained that they fill the balloon with helium. It goes up to about 13 kilometers. The balloon then bursts, comes back down to Earth by parachute, and afterwards, you have to find it. Our balloonists are having a good day. After a perfect launch, the balloon reaches the very respectable altitude of 34 kilometers before blowing up. Finally, in the darkest hours of the night, it's time for amateur astrologers to discover the secrets of the universe. A myriad of experiences to take home with them, almost as many as there are stars in the night sky. Astronomers have been working on a camera that will take clear images of the universe from the ground. Until now, they've been hampered by atmospheric distortions, which obscure part of what can be seen. This system is sharper and much more detailed. The camera takes multiple images up to 100 pictures per second. By sampling them on a computer, the best ones can be selected to give a much sharper view. While the current imaging of space is limited in size, this system can be used over a much wider area. From a scientific perspective, it'll give astronomers a real insight into areas that they call dark matter. Scientists at Cambridge believe the new Lucky imaging camera will be a direct help now to unravelling some of the secrets of the universe. On the first of its 45 encounters with Titan, the Cassini-Huygens mission observed Saturn's giant moon at close quarters. The planet-sized moon looks increasingly like another world. As the data arrived, scientists were elated, but Titan still retains many of its secrets. Although the surface displays highly contrasted areas, scientists remain baffled, not least by the more complex organic molecules than anticipated were detected in Titan's atmosphere. Cassini's navigation was spot on. It passed less than 1,200 kilometers from the moon's surface. This allowed instruments to taste the upper levels of its atmosphere and to survey an area of Titan with a remarkable clarity, with imaging resolutions up to 200 meters per pixel. The surprises? Fewer methane clouds than expected were seen. But from their movement, a first conclusion has been reached. Titan's atmosphere is moving faster than the moon's rotation, a so-called superrotation, like on Venus. Although the surface displays highly contrasted areas, such as this 2,000-kilometer wide view with close-ups, scientists still remain baffled. There's mystery still over eventual liquids that the ISS cameras could have revealed by detecting their different specular reflection of sunlight. Many of the ISS images provided during the flyby show linear features, which might be grooves, striations, or fractures. An extra day of processing was required before the presentation of the much-awaited radar observation of Titan. This was a 2,000-kilometer-long strip in the northern hemisphere, not yet covered by other optical instruments. A wide geological variety is seen. Bright areas correspond to rougher terrains. Darker ones thought to be smoother. Scientists describe Titan as active and youthful. It has unique narrow and very long linear features and many ridges. The young daughter of one radar team member has found a resemblance, and the area has been dubbed Cece, the Halloween cat. Cassini is circling Titan every 48 days. Getting payloads into space is a major headache for engineers. Even a small increase in the weight of spacecraft can mean millions of dollars in extra fuel and components needed to lift a satellite into a stable orbit. The company Surrey Space Satellite Technology has an ability to make smaller, cheaper satellites. The company's long-standing policy is to use ordinary electronic components packed into extraordinary space-proof housing. SSTL also uses smaller and lighter components for its satellites. Through its use of small, simple and lightweight components, the company is at the forefront of multi-billion-dollar contracts to build a series of satellites for practical uses, such as monitoring natural or man-made disaster zones from space. SSTL's profitability and performance look set to soar as high as its spacecraft that are orbiting our planet. The liftoff of the US Space Shuttle Endeavour had some special crew aboard who could help scientists find out more about osteoporosis, a degeneration of the bones that affects 75 million people worldwide. Bone loss is accelerated in space because there is no gravity. The specially bred mice who were blasted off into outer space will receive either a placebo or an investigational protein called OPG, or osteoprotogenerin, during their 10-day flight. Researcher Dr. Paul Kostyunik of Amagen says bone loss that occurs in space is similar to what happens on Earth for those confined to bed rest, although it happens much faster because of lack of gravity. Microgravity-related bone loss, a significant problem for long-term spaceflight, is also a biological consequence of aging. Scientists are hoping that if OPG helps the space mice maintain their bone density, it could help those at risk of getting osteoporosis. Researchers are hoping the out-of-this-world experiment could help scientists find a better way to prevent bone loss down here on Earth.